Go on your web browser to omim.org. Online Mendelian Inheritance in Man is what that stands for. This is a fabulous resource, not just in class, but in life. If you ever hear somebody say, you know, I've got this cousin that has this disease, or my family suffers from this disease, this is a great place to start, especially now that you're going to be learning how to be a critical thinker, or continue learning how to be a critical thinker, how to assess data. So when you go to Omim, so as I suggest here, you can do any sort of number of searches. You could, if you have a disease in mind, if you're curious about something, type it in, see what you find. See what this record looks like. So as I said up here, you can use a genetic disease name. You could use the name of a gene. So you're interested in a particular gene, or I give you an assignment to learn about DNA polymerase gamma. So you go to Omim, type in DNA polymerase gamma, see if there are any known human genetic diseases associated with that protein. Has anybody come up with a disease that has a genetic basis? That is, did you get search results? Which one? Hyperplasia? Excess growth of something? Don't you love autocomplete? Man. Anybody else? Don't have to share, but.
Gaucher disease.
Which one?
Gaucher disease.
Gaucher disease. Yep. So the nice thing about Omim is it's only diseases that have a genetic basis. So if you hit something that's totally environmental, like obesity, there is some genetic predisposition to obesity, so if you type in obesity, you'll probably get a lot of hits. For this example, I typed in, which you can see up here, although just barely, my search term was CAG microsatellites. What does that mean in terms of what we know about microsatellites? Can you help me interpret what you think it means when I say CAG microsatellite? So that'd be a repetitive sequence that's just CAG. CAG, CAG, CAG. So are there any human diseases that are caused by CAG microsatellites? Screenshot, not a live shot, but what do you think? Androgen receptor. So it turns out there are some androgen insensitivity syndromes where males make testosterone, but we can't tell that we're making our own testosterone. So we get a little bit more feminized. I speak we generically, I don't know. Who knows? What else? Machado-Joseph disease, prostate cancer. So there's some genetic component of somewhere in your genome having CAG, 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 CAG has something to do with getting prostate cancer. And then we get down to number 5, spinocerebellar ataxia, which basically, does anybody know ataxia? A means not. Ataxia is usually something to do with gait, walking, something like that. People that have ataxias can't walk well. They fall over. They have poor balance, those sorts of things. There are lots of diseases that have CAG repeats in genes that cause disease. One of you, at least, on day 1 in the quiz survey, mentioned Huntington disease. It's a great example of a pretty common neurodegenerative disease where there's a protein that's called Huntington. HTT is its human abbreviation. It's a gene that makes a protein. The protein's called Huntington. And it tends to be that when you have lots and lots and lots and lots and lots of CAGs inside this gene, you get this disease. If you have very few CAGs, 3, 4, 5, 10 in a row, you're okay. But if that repetitive sequence grows and grows and grows until you have like 20 copies of CAG or 40 copies of CAG or more, then you're heavily predisposed to getting Huntington's disease. So one of the things we get to learn about this term is, why is that the case? Why is it that these simple sequence repeats cause disease? What is it about where they are in the gene, how big they are? What is it about them that causes things like Huntington's disease.